Happy Wednesday, everybody. I hope you are ready to learn something new today. We are going to be talking about arrays and how they relate to multiplication, which you should know from third grade. However, today we're going to be noticing how a basic fact array like this first one isn't really going to help us to solve a larger one like this. Take a look at the first array. Let's look at the things that you already know. First of all, you already know that arrays are made up of rows and columns. There are 1, 2, 3, 4, 5, 6, 7 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So that means this array is made up of 9 columns of 7 or 7 rows of 9. And therefore, it is a 9 by 7 array. We all know that this is a basic fact, and therefore we know that there are 63 yellow squares shaded in. However, when you were first learning this, not everyone was a huge fan of the number 7. So if we look at how we thought about it in third grade, we probably remember using a strategy where if we didn't know a number, we made new ones. So I'm going to show you that if I draw a line this way and I actually partition the array and make 2 new arrays, the top one and the bottom one, the 9 doesn't change. There are still 9 columns, but what I did was I actually split the 7 up into 2 different numbers. There are 5 now, 1, 2, 3, 4, 5 rows above the line and 2 rows below the line. When I add them back together, it's still 7. So I didn't delete any rows. All I did was I made 2 different groups so that I could do the math easier. So all the squares above the line are still in 9 columns, but now there are 5, oops, I almost wrote 7, 5 rows, and there are still 9 columns below the line, but there are 2 rows. What I've just done is something called partial products. I have partitioned, the array into 2 parts to find products that I can use separately. Once I find the 2 partial products, I can add them back together to find the total product of the entire array. So let's check our work. We know that 9 times 5 is 45, which means there are 45 yellow squares above the line. And 9 times 2 is 18, which means there are 18 squares below the line. When I add them back together, I actually do get 63. So even though I already knew my basic fact, what I'm trying to show you is that we are going to use a strategy called partial products today to solve arrays that don't have basic facts that we know. They are going to be 2-digit by 1-digit arrays. Let's take a look at how this works with larger numbers. The array on the bottom here is larger than you've probably seen. One thing I want you to notice is that we're going to be using base 10 grid paper. That is grid paper that has darker lines already drawn in for you with 10 rows across, 10 columns across, and 10 rows down, which helps you skip count. So inside this box, there are actually 100 little squares because I know there are 10 across and 10 down. Keep that in mind. Now that you know that, let's talk about what is the multiplication equation for this bottom array. Well, I know that there are rows and columns that I have to multiply together. I don't want to count all of the yellow squares inside this rectangle. That will take too long. Skip counting could work as well, but there's actually a faster way. So let's talk about what the array actually represents. If I go back to thinking about each box is 10 by 10, I can actually skip count by 10. There are 10, 20, 30, 40, 41, 42, 43. This entire side is 43 columns from end to end. This side is actually 1 less. If this line is 10, it's actually 1 less than 10. So there should be 9, but let's count just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, which means this entire array's equation is 9 rows and 43 columns. Now, like I said, this is not a basic fact. You don't know this. I don't know this, but I can solve it very quickly using the same strategy I used with the smaller array. I'm going to partition one of the sides into numbers that I know. I'm going to leave 9 alone. I like 9. I don't really like 43. The easiest way to split 43 isn't into two numbers that you know, like 13 and 20 or something like that. What you want to do is split it into place value because it's so much easier. What I'm going to be doing is I'm going to be breaking apart the 10s and the 1s. This is something we've been working on for weeks. So let's think about it really quickly. Where do the 10s end? Do they end at 10? Do they end at 20? Do they end at 30? No, they end at 40. I have 4 10s. So I'm going to actually partition this array right there, leaving me with 40 columns on this side of the line and 3 columns on that side of the line. 40 and 3 is 43. Did I change my 9 at all? Did I cut it up, or are there still 9 rows in each box? Well, there are actually still 9 rows in each box. So this side of the array is 40 columns and 9 rows. And this side of the array is 3 columns and 9 rows. What I can do now is find the answer to each part, and then I can add them back together to get the total answer of the entire array. This is partial products. Let's start with the first part. 40 times 9 is the same as 4 10s times 9, which is the same thing as 36 10s. If I know 9 times 4 is 36, 9 times 4 10s is 36 10s. 3 times 9 is 27. Now all I have to do is add it back together. 360 plus 27 is 387. What I've just done is found out that there are 387 yellow squares shaded in the entire array, and I made my job really easy by breaking apart a number that I'm uncomfortable with into place value, because I can do that. Somebody else did the exact same thing, and their answers are gone. But one of the things another person did was notice that this is one row away from being 43 times. So there's 43 across and 9 down. They said there's one more row for 10. So what they did was 43 times 10, and then they subtracted this one row of 43. But we'll talk about that. That's the compensation strategy that I keep telling you about. We will come back to that. So for today, what I want to focus on is partial products. Let's take a look at these arrays. Let's look at the green one. The green one, again, if I use the base 10 grid paper to help me, has 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38. It is 38 columns and 6 rows. The equation for this array is 38 columns times 6 rows. I don't like that. I don't know what that is. Instead, I'm going to break apart one of the two numbers to help me. I'm going to leave 6 by itself, and I'm going to break apart 38 into 30 and 8, which would end here, 10, 20, 30. What are they both multiplied by? Well, this has 30 across and 6 down. This has 8 across and still has 6 down. Nothing happened to the 6. Leave the 6 alone. We did not cut through the side of the 6. We cut through the side of the 38. Now I can solve both parts of the array and then add them back together to get the total. 30 times 6 is the same as 3 10s times 6, which is 18 10s. And then 8 times 6 is 48. When I add 180 in this section plus 48 in this section, the two partial products add together for 228 squares. Thank goodness I found a strategy that's faster than having to count all the squares. The last one I want to do really quickly is this one. There are 10, 20, 30, 42 across the top. Oh my God, computer, let me write. Come on. My computer's not letting me write. Okay, there are 42 across. Oh, there we go. There's all my lines. 42 across and 8 down. I don't like 42, so I'm going to break it apart by tens and ones. There are 40 columns on this side and 2 columns on that side, and the 8 in height has not changed. So there are 40 across and 8 down here, 2 across and 8 down there. This is 4 tens times 8, which is 32 tens, plus 2 times 8, which is 16. Added together, 330. Come on, 336. See how fast you can do math? Today, I want you to try this on your own with base dyed grid paper and your seat work.